here is Professor Tony Bell from Oxford University. He is our guest at our 17th National Conference of Astronomers of Serbia. And Professor Bell, could you please tell me something interesting from your career, from your PhD student days, and from your to make some short review of your scientific career.
Right. Well, firstly, can I say what a pleasure it is to be here in Belgrade. Really enjoyed being at this conference, which is, of course, an astrophysics conference. And myself, I'm mainly a plasma physicist who does astrophysics rather than an astrophysicist. But I did start off in astrophysics. I started off as a young research student in Cambridge, in the radio astronomy group there at the time, when they'd just finished building the 5-kilometre telescope, the Royal Telescope as it is now. And one of the big observations to be made was of the supernova remnant Cassiopeia A, the remains of a star that exploded about 300 years before that. So I was there, a young research student, and I was given this wonderful picture of Cassiopeia A, which was a kind of ring structure on the sky, and it was radio emission, so we knew that the radio emission required magnetic field and it required energetic electrons, and that's true of pretty well all radio emission in astrophysics. And so I set to thinking about how one might actually produce the energetic electrons, because nobody had a good theory of it at the time. And I'd been encouraged by this by my undergraduate lectures from Malcolm Longair and my supervisor, who was Peter Scheuer. And so I put this on as a background activity. And in the end, I was very fortunate to come up with a theory of how energetic particles seem to be mainly accelerated throughout the universe. You know, that if you have a shock front, it takes a small fraction of the particles that pass through the shock, the electrons and the ions, and boosts them up to sometimes tremendously high energies. And you know, the highest energy cosmic rays, as they're called, the high energy particles, have energies up to about 10 to the 20, more than 10 to the 20 electron volts. And this, so I was very fortunate. I think I was in the right place at the right time to come up with this theory, which has, seems to have made its mark and will stay with us. But I should add that I wasn't the only person that came up with this theory. There were 3 other groups of people who came up with it at the same time, sort of totally independently. There was Krimsky in Russia, and there was Blanford and Ostreicher, and Ian Axford and his group. And so it's a strange thing. Maybe that time was just right, and all the things that had come together at that right time to make all of us individually think of this theory.
Professor Bell is inventor of theory called diffuse shock acceleration theory, and from which country is Oxford and Oxford group?
Well, he, I believe, was from New Zealand, but he was working in Germany. Blanford, Roger Blanford, was actually in Cambridge at the same time as me. He was a postdoc and I was a research student, but we were in separate parts of Cambridge, because there was the Institute of Astronomy in one place, and then there was the Cavendish, which I was in another place. And we actually came up with this independently, just within a couple of miles of each other, without knowing about each other. And I remember the time when he found out that I'd done it, and then he came over to see me, and it was quite an interesting conversation we had.
With Blanford?
Yeah, with Roger Blanford, yes, when we compared, because we looked at it, the approach we'd used was totally different, and so it was quite an interesting moment, that.
Okay, but do you have some plans for future, in a sense of?
To keep going. I'm now at a stage where people, you know, I'm over 60 years old, but I don't want to retire. I want to keep going, and I'm still working on it. And there are still many questions to be answered, and still the very highest energy cosmic rays. I think it's true to say that we really don't know where they come from. But one possibility is they come from the relativistic jets that are formed in active galaxies, and so that's what I want to have a go at now, and maybe make some progress on that. But there's still plenty of questions to be answered. Plenty for young people to do.
Yes. Okay. I think that your paper from 2004 connected with magnetic field amplification is very good and very significant paper in this topic. Could you say something about ideas for this paper, for that paper?
Yes, well that was the other big step along the way into, I think, in terms of sorting it all out. But as I said at the beginning, you need energetic particles and you need magnetic field. So the theory I did as a research student about particles is how you produce the magnetic field. And for quite a long time, more than 20 years, it wasn't clear how this could happen, but then I was fortunate again to come up with a theory about how the magnetic field is generated, and it seems that the cosmic rays can do it themselves as they move along, trying to escape the shock. They actually excite some plasma instabilities. And the other half of my research career has been in laboratory plasmas, particularly connected with lasers. And there I sort of got all ideas about instabilities, which I wouldn't have had if I'd worked in astrophysics all the time. But by learning what I'd learnt there, I was then able to sort of move back into astrophysics and maybe have insights about the generation of magnetic field, which maybe I wouldn't have had if I'd been an astrophysicist all my life.
Okay, thank you very much. I think it is
Right, well,
that.
Thank you.